Okay, here we go. Today, you have your introduction to logarithms. Where is Kiesler? That's right. Obviously, she doesn't care enough about it. So, logarithms are awesome. Let's do it. Log base a of x means a to what power is equal to x. Now, we're going to have a number of points today where I'm going to try to explain to you what logarithms are. And you're going to have a tendency to try to just go towards the easiest explanation, but try to take in all the explanations I give you. So first of all, by definition, log base 2 of 32 equals 5. That means that a base of 2 with an exponent of 5 is equal to 32. So logarithms produce exponents. So you can see that the base 6, the exponent 2, produces 36. So 6 to the second power is equal to 36. So you can always take a logarithm and write it in exponential form. How about the next one? 12 to the 0 is equal to 1. Next one, we would have 3 to the 5th is equal to 243. The most common bases that are used are base 10 and base e. So if you see log of x, that's the same thing as log base 10 of x. So you can imagine, when we first started doing, printed materials, trying to produce a subscript was probably pretty difficult. So think of a typewriter. So, how would you produce a base 10? Not saying that that's why they wrote it like that, but so they don't really write base 10. Same thing, log base e of x. What we do is we write natural log of x. Some people get mad that the n isn't before the L because natural log. Well, English didn't come first, folks. Things like Latin and French and other things. The word natural logarithm was originally spoken as logarithm natural in the French language. So the adjective was after the noun. So that's why it's ln and not the other way around. So if you see natural log of e is equal to 1, what that means is the log base e of e is equal to 1. So if you ever struggle with what natural logarithm means, just write log base e. So what would that look like in exponential form then? What's the base? E to the first is equal to e. And it should make sense when you write it. E to the 1 is e. The next one, I won't write log base e. We just see that the base is e, the exponent is 0, and it produces 1. You should also be able to flip it around the other way. Express the following equations in logarithmic form. We should be able to take an exponential equation and write it as a logarithm. So 2 to the 4th is equal to 16. We write log. What is the base? 2 of 16 is equal to the exponent. The exponent is 4. Okay. See if you can do B, C, D, E, and F on your own. Finish off the other 5 on your own. Go. As you finish those 5, you can look up and check to see if you wrote it correctly. Does anybody have a question about what's written? Question going once, twice, 3 times sold. Flip it over. We can evaluate basic logarithmic expressions. Log base 4 of 64, that means 4 to what power is equal to 64? 4 to what power is 64? 3. This means 3 to what power is 1/9? Well, 3 to what power is 9? 2, so if it's 1/9, it would be -2. This means 8 to what power is 8? 8 to the first power is 8. I'm going to take a chance to go a little bit deeper with you in terms of logarithms and help you understand exactly what the heck they are used for and why we need them at all. Okay? Watch this. If you want to take 2x equals 6, what do you do to both sides? Divide by 2. So would you agree that multiplication and division, that those are kind of inverse operations? One undoes the other. What is the inverse operation of addition? What is the inverse operation of a square root? Square, right? Operations have inverses. They undo each other. So for example, if I have the square root of x and I square it, that gives you x. Or if you have x squared and you square root it, you get x, right? Now, my daughter at home, I could convince her after a while. She's 7 years old. Her name is Tenley. Her birthday is on Sunday. She's super excited. She's having her first friend party this weekend. We'll see how that goes. Hopefully nobody gets left out and isn't crying and stuff. So, but we'll see. Do you know what she wants for her dinner? Bacon wrapped sirloins. She wants rice, and she wants cornbread muffins, fresh veggies, and then I don't know what movie she's going to pick for us to watch together, but we'll see. So she's pretty excited. So we try to celebrate birthdays. But Tenley, I could convince her that if you take 4 and you add to it -4, that will produce 0. Whoop, sorry. You could convince her that if you take 5 and you subtract 5, that you would get 0. I mean, she understands that. She has an understanding. But do you think if I tried to explain to Tenley this, do you think she would have any idea what's going on? No, she wouldn't. And I could even ask you, why does it work out like that? And your only response to me is, well, if you want to undo a square root, you just square it. Why? Because that's what you're told. Well, it doesn't really suffice for me, but we've defined these operations, and we've said that they are inverses, and you trust that. Now, if I showed Tenley this, I could eventually say, well, Tenley, do you know these cancel each other out. These cancel each other out. And I could convince her that if she took the square root of y squared, she would say, oh, well, they cancel each other out. I mean, she would learn to accept that, right? Well, watch this. I have y is equal to 2 to the x. Suppose I want to get at the x. What would I do to both sides? The fact is that you would take the logarithm of both sides. Log base 2 of x. These are inverse operations of each other. They are inverse operations. This undoes that. I know that that's weird to think about, but just think about it in terms of the square root and the square and everything else, okay? Try this. If I have y is equal to 2x minus 4, and this is f of x, do you remember from the previous units how we find f inverse of x? What do we do to find f inverse? We switch the x and the y, right? So you add the 4, x plus 4 is equal to 2y. You divide by 2. So x plus 4 over 2 is equal to y. So this is the inverse of that. Well, suppose I start with this. How do I find the inverse? Well, the way that you find the inverse is you switch the x and the y. Now, I do that, and you say to yourself, well, Mr. Gentz, I don't know how to get at the y up there. Well, here's how you get at the y. You take the log base 2 of both sides. And what happens is these are inverse operations. They cancel each other out, and they leave you with just the y. They undo each other. So this will now make sense to you. Flip back to your very first page. And we have these two statements here. And they say the log base a of a to the x. These are inverse operations. They cancel each other out, leaving you with just x. Just like the square root of x squared is x. Just like the square root of x, quantity squared, is x. They are inverse operations. They undo each other. And a to the log base a of x, those cancel, leaving you with just x. Trust that those are true, and watch what happens as we try to then get back to these. Look at this. Log base 4 of 64. Watch what happens. I rewrite it as log base 4 of 4 cubed. Everybody agree that 64 is 4 cubed? They cross each other off. What am I left with? 3. See that? Log base 3 of 1/9. That'll be log base 3 of 3 to the negative 2. They cancel each other off, leaving you with negative 2. Log base 8 of 8 to the 1. They cancel each other off, leaving you with 1. So log base 5 of 5 to the x plus y. What's going to happen? Leaving you with x plus y. These are inverse operations of each other. They cancel each other off, leaving you with just 7. Natural log of 1 over e squared. That would be the natural log of e to the negative 2. Remember, what's the base of a natural logarithm? The base is e, so they cancel each other out, leaving you with negative 2. So that's a pretty cool property of logarithms that we can use. We'll do these 6 right here, then you'll start your assignment, and we'll give you about 10 minutes to work on that before we finish things off. Log base 2 of x is equal to 3. Here we want to use logarithms. We want to solve for x. This would be a base of 2. The exponent of 3 is equal to x. What is x? 8. Here we have a base of x. We have an exponent of 2 equals 100. What is x? 10. Here we have a base of 5. We have an exponent of x is equal to 125. What is x? 3. Base of x, exponent of 1/2 equals 49. I put the problem there so you'd answer 7, but it is not 7 because the square root of 7 is not 49. Rather, what number do you take the square root of to get 49? Well, whatever 49 squared is, right? 2,401. Two to what power is 0? 2 to what power is 0? What's 2 to the first power? 2. What's 2 to the 0 power? What's 2 to the negative third power? 1/8? Can you come up with 0? Ten to the negative third power is x, so x is 1 over 1,000. We're going to pause there. Okay, we want to look at the graphs of logarithmic functions real quick. Yesterday we looked at exponential functions, and you learned that the exponential function goes through what point? 0, 1. Very good, because anything to the 0 power is 1. It had a horizontal asymptote. The horizontal asymptote was just like this. Well, what I told you today is that logarithms and exponentials are inverses. If you remember from chapter 2, we said that inverses were reflected over the line y equals x. So that means that all the x values become y values, and all the y values become x values. So instead of passing through the point 0, 1, it's going to pass through the point x and y switch, 1, 0. Instead of having a horizontal asymptote, it's going to have a vertical asymptote. Logarithmic functions come right from exponential functions. The domain here was all real numbers. So the range for this one will be all real numbers. The range here was from 0 to infinity, so the domain here will be from 0 to infinity. If you remember when we did inverses, all that stuff just switched places. So let's look at our problem. It says, write an equation for a logarithmic function that passes through the following points. Notice these ones go through 1, 0 and not 0, 1. This is the x value. This is the y value. We want to write y equals log base a of x. 2 equals log base a of 25. What does that mean? That means what number do you square to get 25? So a is 5. Am I done? No. You have to write it as a base of 5. Y equals log base 5 of x. Next one, this is x, this is y. -1 equals log base a of 1/6. What number did you raise to the -1 power to get a 6th? 6. So y equals log base 6 of x. This is x, this is y. 4 equals log base a of 10,000. What number did you raise to the 4th power to get 10,000? A is 10, so therefore the function is y equals log base 10, or just log of x. You don't have to write the 10. And the last one, this is x, this is y. 1 is equal to log base a of x. Whoop, of 7. What number do you raise the first power to get 7? That is 7. So y equals log base 7 of x. We good? Flip it over. We're going to do 3 of these problems. Just remember how to graph them. We'll do A, B, and C. This is sketch the graph of the following. Say domain, range, asymptote, and 1 point on the graph. I will start with the parent function. We just talked about the parent function having that shape. Looks like I didn't do a very good job of going through the point. I'll try it again. The domain was from 0 to infinity. The range was all real numbers. And the asymptote was x is equal to 0. That's the parent function. That's what we want to focus on. You tell me what's the transformation for y equals log of x plus 2. Is the 2 on the outside or inside? Outside. So is that going to affect it vertically or horizontally? Vertically. So move it up 2. Does that change the asymptote at all? Nope. So the asymptote stays right there. Does it change the location of this point? Yep. It moves it from 1, 0 to 1, 2. What is the range always? We see that the point is 1, 2. The asymptote is still x is equal to 0. The domain is everything to the right. So the domain is from 0 to infinity. How about the next one? What's the transformation for the next one? 2 to the right. Is that going to change the location of this asymptote? Yep, it will. It's going to move it over 2 units. So therefore, the asymptote is x equals 2. Will that change the location of the point? Yep, moves it over to 0 or 3, 0. The range is always all real numbers. How about the domain? Look at your graph. 2 to infinity. If you look at the function, you guys, it's 2 to infinity. You can never take the logarithm of 0 or a negative number. It's another way to think about it. You can never take the logarithm of 0 or a negative number. So you see we go from 2 to infinity. And the last one, does the plus 1, what does that do? Left 1. So my vertical asymptote moves to the left 1. The asymptote is x equals negative 1. What is the minus 3 going to do? So I move left 1 and down 3. So you can see my coordinate is 0, negative 3. And then what does the negative do? Is that a vertical flip or a horizontal flip? Do you remember? Vertical flip. So it's going to start up and finish down. So we have a domain from negative 1 to infinity, and we have a range of all real numbers. Sorry for going over. We had a little technical delay there. Have a great